Good morning, everybody. My name is Manuel, and I'm happy to introduce to you the topic I've been working on for the past few months. I was working under the supervision of Professor Margarida Castro from CCMAR and from Dr. Ayla Campos from the BA's Institute of the Sea and the Atmosphere. And I've been looking at the spatio-temporal factors that were affecting variations in biomass and mean length of three commercially important species along the coast of the Algarve in southern Portugal. So the structure of my presentation is going to go like this. First of all, I'm going to start with a short introduction on the fisheries in Portugal, the importance of rhythmicity of organisms in these fisheries, and the species of interest that I've been looking at in my investigation. And then I will go on with the aims and expectations of my study and how the data was collected and analyzed. Then I will present to you my results, which I will discuss at the same time. And I will finish with the limitations of my study and the further improvements and a short conclusion. So Portuguese crustacean fisheries operate in the south coast and southwestern coast. For my study, I was only looking at the south coast, so the coast of the Algarve. There's around 30 vessels operating at around 50 meters to 750 meters depth. And over the past few decades, there's been an improvement in fishing gear technology and as well as an increase in fishing effort, which has led to a really high increase in fishing pressure for the communities present. So here you can see the catches, the annual catches of the three species I'm going to present to you now. First of all, we have Parapenaus longirostris, which is the rose shrimp. It is found between 80 and 700 meters depth. It displays seasonal differences in abundance, and the only regulation it has in Portugal is the minimum landing size of 24 millimeters carpus length. Then we have Nephrops norvegicus, which is the Norway lobster. It is found between 20 and 800 meters depth. It displays a burrowing behavior, so it lives in sandy or muddy substrates, and therefore it has periodical emergence. And it is the only one that, due to its wide range from Northern Europe to Northern Africa, that is managed in an international manner. So it was subjected to a recovery plan in 2005 because it was observed that the landings were sharply decreasing. And lastly, we have Aristeus antenatus, which is the red shrimp, and is found between 400 and 1,500 meters. It displays seasonal bathymetric migrations, and the minimum landing size in Portugal is millimeters carpus length. So it is clear that rhythmicity affects the availability of these organisms to the fisheries and is therefore very important to understand it. The aims of my study were to understand variation patterns in biomass and mean length, and my expectations were that we were going to observe interannual variations due to fishing pressure, seasonal variations due to the reproductive cycle of these organisms, and bathymetric variations due to the population dynamics. This table presents the campaigns through which the data was collected. So there was a total of 398 hauls, all performed through 15 sampling campaigns. You can see that there's both research and commercial vessels, and that were operating from 1993 to 2008, although some years are missing, and through all seasons except for winter. Here you can see that the initial purpose of these campaigns were not for my study. They were done for other studies, such as the selectivity of the nets or the survival of individuals escaping from the nets. And you can see here as well the species of interest for each study. And they are marked as the 3 alpha codes from the FAO. So NEP is Nephrops norvegicus, ARA is Aristeus antenatus, and DPS is Parapenaus longirostris. So I had 5 independent variables, 2 spatial, which were longitude and depth, and 3 temporal, which were year, month, and hour, and 2 response variables. The first response variable was biomass, as in grams per square kilometer, and it was calculated with the following equation, which is the swept area equals the boat times the trawl duration times the constant that converts knots into kilometers per hour, and times the dimension of the trawl divided by 1,000. And then my other response variable was mean length. For biomass, I did a 2-phase model. First of all, I was modeling the predicted presence, And where presence was predicted, I ran the second phase of the model, which was predicting abundance, so biomass. And for mean length, I only had the one phase model, which was only a generalized additive model on the mean length. These GAMs, they provided me with two p-values. The first one was showing me the effect of the linear effect of the variable, and the second p-value was showing me the nonlinear effect, or the spline. So my results, unfortunately, I won't have enough time to show to you all my results, so I will discuss some specific ones for each variable, and I will shortly discuss the other ones. So in here, for the longitudinal variations, we can see for Aristeus antenatus that there's an increase in biomass from east to west in the coast of the Algarve. And on the contrast, you can see that there's an increase in size on the easternmost side of the Algarve. So the biomass can be explained by oceanic currents that promote recruitment in the westernmost side of the Algarve, and bigger individuals being present on the other side of the coast can be explained maybe by the lack of competition, which makes more resources available to the organisms that are present. And similar patterns were observed for Nephrops norvegicus and Parapenaus longirostris. For the effect of depth, I'm going to speak to you about Parapenaus longirostris. We can see that there's a decrease in abundance with depth, and we can also see that there's an increase in mean size with depth. So this has been observed before. It was reported in previous literature, and we can maybe explain the in size with depth with the lack of competition again, because there's less individuals at deeper waters, so more resources available. There was also interannual variations that were observed for all three species. I'm going to speak to you again of Parapenaus longirostris, and you can see that there's an increase in biomass from 1993 to 1998, and this can potentially be explained by the fact that there's the Guadiana River nearby, and it was reported to dry up. So the inflow of fresh water in the coast decreased significantly at the beginning of the 1990s, and the salinity has been shown to positively affect the biomass of deep water shrimps, such as Parapenaus longirostris, and the subsequent decrease, so from 98 to 2004, it can be probably explained by the increase of freshwater input from the river. And we can see that there's a clear contrast between the mean length and the biomass, which can potentially also be explained by the same ecological factor, which is the lack of competition and therefore more available resources. Also, monthly variations were observed for all three species. Here I'm going to present Nephrops norvegicus. You can see a low peak in biomass in March and October, as well as an increase in between May and July, and a decrease in mean length from June onwards. And this can all be explained by either the reproductive cycle or the molting periods of the species, because individuals that have females that have that have reproduced, so are buried, they spend more time buried and they emerge less often, same as individuals that are molting, they remain in their burrows. As for diel variations, it was only observed a significant effect of the time of the day in the biomass of Nephrops norvegicus and Parapenaus longirostris. And this is in accordance with previous literature that say that there's always a peak in activity around midnight or midday, or 1 p.m. And it can be explained by the light intensity. In the coast of the Algarve, it was reported that Parapenaus species, sadly, I did not have day-night cycles, so I could not corroborate this information, but maybe if I had more information on the or more holes performed at night, I could have seen this pattern as well. The limitations of my study was mainly the lack of dedicated experimental design, because as I mentioned before, I did not have, the sampling campaigns were not performed for the purpose of my study initially. taking the same variables into account. For example, I only had sexing of individuals in 2 of the campaigns, and therefore I could not use this factor. And there was a poor representation of years and months. I did not have data for 95 and 96, or for September, or for any months of the winter. For further studies, it would be interesting to look at combined effect of factors, because it is likely that the variations are not driven only by one factor, but more like a conjunction of the factors, for example, depth and season, or salinity, for example. So it would be interesting to look at additional variables, such as sex or the ovidual state of the females, substrate type, light irradiance, current speed, salinity. And it will also be really interesting to look at it more in an ecosystem-based approach, because it is evident that the presence and the abundance of an organism is dependent on the presence and abundance of their predator and their prey. So it would be interesting to look at it in a more wider approach, to look at all the species present in the ecosystem and that affect their presence rather than just the species individual. So to conclude, the spatial variations that were observed in all 3 species were most likely driven by ecological factors such as competition, or by hydrographical factors such as currents or salinity. The temporal variations that were observed in all 3 species, again, were likely to be driven by ecological factors such as reproductive cycles or molting, and anthropogenic factors such as fishing effort. And we can see that the recovery plan that was implemented for Nephrops norvegicus had a positive effect, proving that it actually worked. And the lack of experimental design, of dedicated experimental design, might have biased my results, but it is still interesting to take this into consideration if we want to implement further conservation measures for the species. So I would like to thank, first and foremost, my supervisors and my promoters, so Margarida Castro and Aida Campos. I would like to thank also my friends and family for supporting me through this process and through my studies. And I would like to thank the audience for listening to me.